Welcome to the Deep Dive. Today, we're plunging into a really essential topic, energy.
Absolutely critical.
We're digging into insights from a recent chat with Scott Tinker. It was on YouTube, billed as an honest take on the looming energy crisis.
Right, and the idea was to give folks kind of schematic understanding.
Exactly, of the structures our, abundant world depends on.
Structures we probably take for granted.
For sure. So our mission here is to pull out the key ideas from that source, looking at energy's link to prosperity, the environment.
And exploring the story they present, one you might not hear other places. They frame it as accurate, helpful for seeing, well, opportunities.
Yeah, and the source mentioned how often future narratives are, well, terrifying, and contrasted that with what it called an invitational vision. Abundance for everyone, if we set our minds to it.
That's an interesting framing right off the bat. Not just technical, but competing visions. Fear versus possibility, scarcity versus abundance.
With energy right at the center. Okay, so let's start where the source does. It makes this really strong claim. If you care about people struggling, there's nothing more important than energy. How do they build that case?
Well, it ties energy directly to, what people do, to human activity, well-being. The material argues there's basically no real difference between energy and work.
Energy equals work.
And then work equals wealth. So energy isn't just flipping a switch, it's the engine.
The engine for economic development.
Yeah.
Human flourishing.
That's the argument presented, yeah.
And when you think about providing that engine, the source highlights two really crucial things.
Two cardinal concerns, yeah.
It's not just having the abundance,
Right.
but also the reliability, how dependable that supply is. It says reliability is as important as provision.
Flat out. And that reliability piece, wow, the source really dives into the challenge of just managing an electrical grid.
Especially where we live, right? In the developed world, you just expect the lights to be on.
24/7. No flickers. You don't even think about it.
But making that happen, especially now, it sounds incredibly complex.
Oh, yeah. Particularly when you add in sources like solar and wind, the intermittent ones.
Which the source points out.
Right, because, physics. The sun sets, clouds roll in.
The wind stops blowing.
Exactly.
Yeah.
They even mentioned that German word, Donflaut.
Wind drought.
Yeah. And when those sources drop off, something else has to pick up the slack. Instantly.
Like in real time.
In real time. Keeping that grid stable with those fluctuating inputs, the source calls it brutal.
And they give an example, right? This isn't just theory.
No, not at all. They use that really stark example, the Spanish blackout.
Yeah. Affected Spain, Portugal, France.
And the Telegraph apparently called it the worst electricity failure in any developed country in modern times.
Wow.
And what's really striking, the source mentions this accusation, supposedly from Brussels sources.
What was the accusation?
That the authorities were basically conducting an experiment before the system crashed.
An experiment? Like pushing renewables too hard?
That's the suggestion in the material. Pushing them too fast while phasing out nuclear, maybe acting recklessly. It even noted something about an inexperienced person maybe being put in charge of the grid then.
So it wasn't just tech failure, potentially policy and management.
That's the implication presented.
Yeah.
Decisions matter.
Okay, so reliability is crucial, non-negotiable. And mixing in intermittent sources needs serious backup and management.
Definitely.
Let's shift gears a bit. Another fundamental concept the source focuses on. Energy density?
Density. Yeah, this is a big one for them.
How do they explain it simply?
They use that analogy, kale versus cow, for calories.
Right, you need a mountain of kale.
To get the same energy as, a small steak. It's how much punch is packed into a certain amount of stuff, weight or volume.
And the source traces human history through this lens, doesn't it? Finding denser and denser fuels.
Pretty much. Started with biomass, hay, wood, dung.
And they make that really important point about the world's poor. Billions still rely on that stuff.
Leading to horrific indoor air pollution. They cite, 3 million deaths a year from that smoke?
It's just awful. So from wood and dung.
To nature concentrating it for us. Cold, denser plants, basically. Then oil. Then natural gas, even denser by weight.
Each step up unlocking more
A
possibilities.
huge lever for progress, yeah.
But the really massive leap in density, according to the source, that's nuclear.
Uranium and thorium. The source says it's 1 million times denser than wood per unit weight. 1 million.
That's hard to even grasp.
Totally. And they point out a nuclear reactor fundamentally, it's just using fission to make heat.
To boil water.
To boil water, turn a turbine. Same basic principle as burning coal or gas, just radically different, incredibly concentrated heat source.
So they had that example, didn't they? The pellet.
Oh yeah, the uranium pellet. Tiny thing, like a centimeter tall. Has enough energy, they say, to drive a car from New York to LA.
Wow.
And back to Dallas. In one little pellet.
That really puts the density thing into perspective.
It does, and it matters hugely for practical stuff, like transportation.
Right. Anything that has to carry its own fuel.
Planes, rockets, even heavy trucks. You need dense fuel.
They mentioned the battery weight issue, right, for electric vehicles?
Yeah, a Tesla S battery pack weighing, what, 1,000 pounds? Compare that to jet fuel or diesel.
Big difference.
Huge. And the source makes the point that, electrons can do a lot, but molecules are still needed for tons of things.
Like fertilizers, plastics.
Exactly. Things electrons just can't replicate.
So density isn't just physics. It shapes what's possible.
Directly impacts what we can do, yeah. Especially heavy lifting, long distances.
Okay. This connects nicely to another core argument in the source material. This triangle relationship.
The energy economy environment triangle.
Yeah, what's the central idea there?
The core principle presented is pretty straightforward. Healthy economies, wealthy economies, are the ones that can actually afford to invest in cleaning up their environment.
So wealth enables environmental protection.
That's the argument. The source claims the cleanest air, looking at particulates anyway, is where it's rich. The worst is where it's poor.
Why?
Because the poor places simply lack the resources, the capital, the technology to tackle the pollution. They're focused on survival.
So the source argues if you want clean air, clean water, clean land.
You don't suppress economic development, you accelerate it. Accelerate human flourishing.
That seems counterintuitive to some narratives.
It definitely pushes back. And it uses Germany as an example again.
What does it say about Germany?
It claims that by following what it calls the idiot green road, Germany made its power more expensive.
Okay.
Less reliable.
Right.
And dirtier.
Yeah.
Failing on its own environmental goals, not just economically.
Wow. And it dismisses degrowth.
Calls it rebranded failure. The view is that pushing for less, for scarcity, actually harms the environment in the long run.
So how do we get to a sustainable future, according to this source?
By eradicating poverty, lifting people up economically. That, the argument goes, allows people and countries to take a longer-term view to prioritize and afford environmental care.
So prosperity enables stewardship.
That's the perspective. They're not seen as enemies, but partners. Economic strength makes environmental progress possible.
Okay, let's look globally then. The source describes this huge energy divide.
Yeah, it paints a stark picture. It talks about, 1.4 billion people in the developed world.
Us, basically.
Right. Averaging around 50 megawatt hours of energy use per person per year, and about $50,000 GDP per person. They call it the 50-50 statistic.
50-50, okay.
And then there's everyone else, the other 7 billion people, way below that.
How far below?
Well, it mentions 4 billion sort of emerging, but stuck at maybe 1 to 5 megawatt hours a year, and only $1,000 to $5,000 GDP, a huge gap.
And the source calculates what it would take to bring everyone else up.
Yeah, up to something like that developed world 50-50 level.
And the number is?
Staggering. It would mean almost tripling total global primary energy consumption.
It's tripling. From where we are now?
From about 620 exajoules today, the source calculates, up to nearly 1,800 exajoules.
Wow. Okay, that's a lot of energy.
A massive amount. And this loops right back to density.
Because meeting that kind of demand
absolutely requires using the densest energy forms we have. You just can't scale that high with diffuse sources alone, according to this argument.
But hang on, isn't the standard story that we're, running out of those dense sources, fossil fuels especially?
Yeah, the running out narrative, the source tackles that directly, calls it a silly notion.
Really?
Yeah, says we're not out of energy options, we're out of ideas.
Okay, bold claim. What's the counter argument?
It's basically rooted in economics and innovation. We don't actually run out of commodities in the way people imagine.
How so?
Because as something gets scarcer, its price goes up.
Right.
And that price signal does two things. It makes people use it more carefully, and crucially, it massively incentivizes finding alternatives or better ways to get it. Innovation kicks in.
They mentioned that bet, right? Simon versus Ehrlich.
Exactly. The economist Julian Simon bet the biologist Paul Ehrlich that the price of a basket of commodities would fall over a decade, despite population growth.
And Simon won.
Simon won. Because human ingenuity found ways to get more, use less, or substitute.
So it challenges that Malthusian idea, humans multiplying until resources collapse.
Directly. The source says the human environment is unbelievably malleable. We can adapt, we can innovate, we can switch the substrate, as it puts it, find new resources or new ways to use old ones.
Does it offer evidence for current abundance?
Hmm.
Beyond just theory?
Oh, yeah. Starts with natural gas. Claims the U.S. has hundreds of years of supply.
Hundreds. How?
Primarily the fracking revolution that the source highlights.
Okay, explain that simply.
Basically figuring out how to drill down and then sideways into shale rock and then crack it open to release gas and oil trapped in these tiny, tiny pores, nanometer scale.
And the impact?
Huge. Since around 2007, 2008, shale gas went from maybe 4% of U.S. production to like 70%.
Wow.
And shale oil from almost nothing to over 60%. And the source claims we've only produced maybe 5% of what's actually in those U.S. shale basins so far.
Just 5% tapped.
According to the source material, yeah. Still vast potential there.
What about globally?
Even bigger potential suggested. The material mentions places like the Middle East, Russia, having even larger, more mature source rocks than the U.S.
But they aren't fracking much yet.
Not at scale, no. Because they're conventional oil and gas, the easier stuff to get is still cheaper for them to produce.
Interesting. The source even hints at geopolitical reasons for some anti-fracking sentiment.
It touches on that, yeah, suggesting maybe some funding came from places whose market share was threatened by the U.S. shale boom. A complex picture.
And looking even further ahead, beyond shale.
The source mentions hydrates, methane locked in ice, mostly under the oceans and in permafrost.
How much is there?
Potentially bigger than anything we've talked about, it says. Huge resource, currently expensive to get, but technology could change that.
And abiogenic gas.
Right.
Gas not from fossils.
Briefly mentioned, yeah. Evidence from the Deep Carbon Observatory suggests some natural gas might form deep in the Earth, non-organically. Still debated, but it challenges the idea that all gas is finite fossil fuel.
So the overall picture is we're not about to run out.
Not in the simplistic sense, according to this source. Fossil fuels aren't infinite, sure, but they won't just disappear.
What happens then?
They'll likely get too expensive for some uses, like maybe burning for electricity eventually, but they'll stick around for essential things where molecules are needed.
Fertilizers, plastics, jet fuel.
Right. Things that are hard or impossible to do with just electrons. Other energy sources will take over other roles. It's an evolution, not an empty tank.
Okay. Given that perspective on abundance and density, the source loops back strongly to nuclear.
Yes, particularly regarding CO2 emissions.
How so?
It claims the best solution for tackling CO2 is clearly nuclear, period.
And points to France.
As the prime example, a country that built a largely zero-carbon electricity grid, primarily with nuclear power, it showed it could be done.
Which leads to what the source calls the mystery.
The mystery. If nuclear is zero carbon in operation, why are environmental groups, the Greens, as the source puts it, often so anti-nuclear?
Citing Spain and Germany phasing it out.
Exactly. The source suggests this implies the story driving the opposition is not about carbon dioxide pollution, it's about something else.
Interesting angle. Does it talk about new nuclear tech?
Mentions small modular reactors, SMRs, and points out, hey, we've had small reactors for ages.
Submarines,
Yeah.
aircraft carriers.
Right. It's not a totally new concept, and newer designs, like thorium reactors, are presented as potentially radically safe.
But there's still the fear factor, right?
Huge factor. The source acknowledges fear is incredibly powerful, can shut down logical thought.
Compares it to Cold War fears.
Yeah. The fear of the bomb, then, versus the fear of climate change now baked into younger generations. But it stresses the bomb and the power plant are not the same thing.
Okay. This connects to the bigger picture again. Fear, narratives, and population.
Right. The source brings population dynamics back in, makes the point that wealth tends to drive fertility rates down.
Not up.
Down. And fertility rates are plummeting almost everywhere except, currently, parts of Africa. This flies in the face of those old Malthusian predictions of endless growth.
So population might actually peak.
The projection mentioned is maybe around 2075 and then potentially decline, a very different future than the one Ehrlich predicted.
So let's pull these threads together. The source argues for energy abundance.
Yep.
Says energy lifts people from poverty, which enables environmental care.
Right.
Highlights dense energy sources like nuclear and fossil fuels as key. And says we have plenty. And points out population trends that counter scarcity fears.
You put all that together, and then you hit the wall the source keeps pointing to.
The central mystery.
If this positive, fact-based vision of abundance is plausible, why the hell aren't we doing it?
And why is there this other narrative, this utterly destructive counter-narrative?
Yeah, where does that come from? The material suggests some roots in the 60s, environmental scares like Silent Spring,
Which it frames as concerns affordable to the wealthy.
combined with flawed Malthusian ideas. Paul Ehrlich, again, the Club of Rome report, ideas about limits to growth.
And it sees echoes of that today.
Points to things like the C40 Consortium's proposals.
What kind of proposals?
Cites examples like, owning only 3 new clothing items a year, a 95% cut in car ownership.
Wow, that sounds restrictive.
The source calls it a vision of scarcity and argues that actively pursuing scarcity will make environmental problems worse, not better.
And involves loss of freedom.
Removal of choice and basic human freedoms and liberties is the direct quote used. Strong words.
And this scarcity vision ignores history, according to the source.
It argues it does. Ignores how denser energy improved environments historically.
Like switching from wood fires to LPG or induction, saving forests, saving lives.
Exactly. Or oil replacing whale oil, saving the whales. Density solved environmental problems.
The source also briefly touches on climate models.
Yeah, it mentions the latest big IPCC report, AR6. Points to a specific table, 12.1.
And what does it claim that table shows?
It claims the table shows limited observed extreme weather impacts that can be attributed to climate change with high confidence so far.
Okay, so far being key.
Absolutely. But the source uses this to argue that while climate change is real and needs addressing, it's not an existential threat right now. Meaning we have some time to act wisely, effectively, not rush into potentially damaging policies based on panic.
What is presented as dangerous then?
The growing gap, the disparity between the developed world, the 1.4 billion, and the other 7 billion.
The energy divide.
Yeah, because people with nothing to lose have nothing to lose. That's described as very dangerous.
And there's pressure on developing countries.
Huge pressure, the source says, especially Africa. Pressure to leapfrog straight to intermittent renewables, skip the reliable, affordable energy needed for basic development.
Even though everyone sees what the developed world has.
Exactly. Cell phones mean no secrets. Everyone knows what abundance looks like. Denying them the path to it, that's seen as deeply problematic.
So the conclusion from the source is what? What needs to happen?
It has to happen. We need to unleash energy.
Unleash it.
Yeah, dense energy specifically, using all forms that make sense in context.
Solar, wind where they work.
Sure, but also nuclear, natural gas, especially for molecules, oil, even coal where needed for transition for reliability.
The goal being?
To bring everybody up, lift those 7 billion, the source is adamant. The most appropriate way to serve the poor is to make energy radically available, reliably, period. It's a really powerful reframing, arguing that expansion, abundance, leveraging our best tech, that's the real path to global well-being and environmental health, not constraint.
That really captures the core message from this material, doesn't it? Access to energy-dense, reliable energy is the foundation.
The foundation for lifting people from poverty.
Which, the argument goes, is the pathway to a cleaner environment and a world of opportunity. Abundance, not scarcity.
And the resources, they argue, are there. We're not out of options.
Which leaves you, the listener, with a big question the source seems to grapple with.
If the facts point towards abundance, prosperity, and environmental solutions through energy, why is the dominant public story so often about scarcity, limits, and fear?
What does that gap tell us? Who benefits from that fear narrative? And based on all this, what kind of future vision do you think makes sense? Something to chew on.